Hey everybody. So I wanted to run through one more time and do one more bootstrap, mostly because your assignment requires you to do a second bootstrap, right? Create a hypothesis test on a non-parametric statistic. I'll give you some ideas here: median, mode, min, and max. You could come up with some others. What I don't want you to use is I don't want you to use the mean, and I don't want you to use the standard deviation. Those have very specific ways to do them, so we don't want to duplicate that. Okay, so what I would like to do then is go through and show you guys how I did it. So I have my little note to start here. This is the same file that I've been working on for a while. And what I have open is my data set. I just called my data set, right? One of the things that I did last time was I omitted my NANs, and I need to fix that. I was looking at games played, and the Dallas Stars actually had not played a game yet because of COVID procedures, because they were in COVID restrictions. And before I just did like NA and NA.omit or something, and just got rid of that. Let's see if we can scroll up and show you guys NA.omit, and then I just got rid of that would get rid of omits the NA, the not there data. Right, this game played, Dallas Stars don't have any game played. I don't want to do that though. I don't want to do that because I'm actually going to look at the minimum. So what I'm going to do here, guys, is I'm going to run this little piece of code. And what it does is it goes through and asks, is the data NA in data games played? And where that's true, we're going to replace data games played with the value 0. So let me hit run and show you guys what that looks like. So it has all the games played, and then it has the 0 at the end for the Dallas Stars here. So let's go back to the first page and make sure you guys can see that right. 4 games played, 3, 4. Everybody see this lining up? 3, 3, 3, 3, a bunch of threes. And then at the end here, well, there's the Dallas Stars all by themselves, but we can see 4, 3, 3, 4, 4 working backwards. So there you go. So I've replaced the NA with a 0. Now, I know that is true, right? I know that not being here means it's 0. Average age is not 0. So that wouldn't be a good place to put a 0. But wins and losses and overtimes, losses, and points, those are all 0s. So I could put it there, right? Make sure if you're doing a replacement like this, if you're replacing an NA value, not their value, that you do it correctly. This can throw off your statistics. And I do think, by the way, I do think it threw off my statistics up here. I probably should have replaced that with a 0. Okay, so I want to run the next thing. I do that same weird thing I did before for the bootstrap, where I write a little function that just calls the min, but it calls the min and it allows the bootstrap function to go through and select which ones it's going to pick. So you have to do that. You have to call this function. Then I call my bootstrap. I call it on my data that's games played. That was this thing that I just showed you here. I ask it to work on the sample min, that's this function here, and I ask it to do 10,000 replicates this time. I asked it to do more replicants because when you have the non-parametric statistics, it is not normal, so you have to run more replicants to make your data look okay. Notice my T, my histogram, my bootstrap distribution is not normal. So this is a little worrying. This should worry you if you're using normal procedures on it. So I should not use normal procedures, although I'll go ahead and show you the normal procedures here. Results is what I called the bootstrap. And so I've taken the mean of the results, $T. If we remember from above, $T on the results on the bootstrap gave us all of the bootstrapped data. So it'll be 0, 2, or 3 for the minimum number of games up here. And that's the minimum on each bootstrap sample. I also did the standard deviation, and then if I wanted to get some 95% confidence interval, I do x bar minus 2 times the standard deviation and x bar plus 2 times the standard deviation. And again, this is technically it's the standard error. The standard error is the standard deviation of the results. This is very, very suspect. Very, very suspect, because this histogram is not normal. This is a very normal thing that I'm doing here. I can do it though. So there it is. You should notice that negative 1.3 being the number of games played seems very suspect. Minimum number of games played, 2.8, maybe not so much, but we do see there's a whole bunch of threes. So, you know, there's even more threes than there are twos. So it seems pretty odd that that's my confidence interval. So I really prefer that when you run your Bootstrap, you go ahead and you do the confidence interval as a percentile. So if I do that, I get a percentile, and you see here, what it does is it's going to pick out, it's going to throw away the bottom 2.5% and throw away the top 2.5% and just give you the 95% in the middle on this scale here. So the confidence interval for me is between 0 and 3. And these are actually Bootstrap, from the Bootstrap distribution. So I really do prefer you don't do this normal thing when your data is not normal. Do the percentile thing. Last thing is I asked for a p-value. I haven't done a null hypothesis here. My null hypothesis probably be something like the minimum is equal to 0 because it was, I don't know, something like that. But if I wanted to do a p-value using the percentile idea, I can ask for 0 to equal the minimums. These are all the results, right? And I did a mean of that, and that will give me a percentile. So about 63% of the results are equal to 0. I think this number is actually exact because there were 10,000, right? And there's 4 decimals. If I asked for for how many equaled 1, it should give me 0. There were no 1s in that Bootstrap. If I ask it for 2, I think there's a few, 32. And if I ask it for 3, about 5%. And if I ask it for 4, it should give me 0 again, right? So that 3 is pretty interesting. Might be the thing I should hypothesis test. Is the minimum number of games the team played 3. Now, one of the things that's really weird, guys, is that when we're doing these non-parametric statistics, there aren't the formulas. So I really do have to do some kind of bootstrapping if you want to say something about like what's the minimum height in a sample you would suspect. Well, it's pretty rough to do. You can't. There is no parametric method. There's no formula. I can't point you to a t-statistic or something and say you'll be able to do it. You really would have to do some kind of bootstrapping thing to get that. So minimum, max, median, and mode are those ideas. So hopefully this gives you guys an idea. Let's double check that I did everything right. Well, I didn't create the hypothesis test. I kind of did, right? I used the Bootstrap method, and I got a confidence interval. I need to properly state my conclusion. If it's 3, if I thought the mean was 3, I would go ahead and reject my null hypothesis because my p-value is low, less than 5%. And I did compute a p-value. My p-value here is 4.59%. So there you go. That is what I'm looking for you guys to do on this one. Make sure you're writing, guys. I'm saying a lot of stuff and not writing it here. I'm just doing the coding. I really want to read. I'm not going to understand just by you doing the coding, right? I'm going to understand that, oh, like, look, I'm looking at the minimum. I think the minimum is 3, and then going from there. Remember, guys, in my original sample, the minimum is not 3. The minimum is 0. But what we should suspect is that this 0 is an outlier. The Dallas Stars had COVID and weren't playing yet. So that really is like a weird little outlier. Shouldn't be there in the data. It's something weird going on. And we kind of see that. But I will say that, 0 wasn't all that odd. Again, the minimum's a weird thing to test, right? All right. Keep working hard, guys. You guys got this.